here we go again with our next presentation, and we're going to try this one without my face on the screen. And when I get to class, you can tell me whether you liked it better this way or with my face on the screen, and I will not take any offense at all. Alright, this one's about our third kinematic equation, and it's also what happens when we are slowing down. So let's get started. First of all, let's try this one. Here's a problem similar to what we've done before, but this time the object is coming to a rest instead of starting in a rest. As usual, we'll identify the information. So the initial speed is the 40 meters per second. They come to a rest, so the final speed is 0, and that happens in a time of 5 seconds. And we are looking for the acceleration. Well, this equation will work well for us because it has the thing that we're looking for and also has the other three variables as well. So we should be familiar with this equation by now. By plugging in the numbers we have, we're going to end up with this. And what I'm going to do with my algebra here is I'm going to try to get rid of the 5 and the 40. But since the 40 is farther away from the acceleration, I'm going to get rid of it first by subtraction. And that's going to give me a negative 40. And then to get the 5 to the other side, I'm going to undo that multiplication with division. And there I get my answer of negative 8 meters per second squared. But it's also my answer for how I'm going to mathematically represent things that are slowing down. For our class, if you're slowing down, you'll have a negative for acceleration. Okay, well, that brings up something interesting for us mathematically, and that is the negative sign being used to indicate the slowing down. Okay, we're also now going to try to combine some of the stuff that we've already done. We have three things that we've done before, and that is the average speed, and we've talked about that equation, and also that the average speed is the initial plus the final divided by 2. By combining these two concepts, I can get a third equation. And it's a little tricky. Maybe we'll do it in class. Ask me if you're interested. And if we did combine the equations, we would end up with this third equation over here. So yes, we probably will discuss how those are combined to come up with this third equation. But if you really want to challenge yourself, that's a good one, trying to see if you can figure that out. The main skill for us right now is to be using this third equation. So let's do a couple of examples together to help you get comfortable with it. Okay, so here's a problem, and it might be a good idea to pause and see if you can solve it, and I'll be back with you as soon as you hit the pause button again. All right, welcome back. Let's see how you did. All right, first step, of course, is to identify the information. So here I've identified the information, including the thing that I am looking for, and that is the distance. So with my new equation, this new equation is going to be good because it has the distance that I'm looking for, but it also has all of the other things that I know from this problem. So I can go ahead and substitute them, and when I do the first time around, it looks like this. Something that often gives confusion on this is the squared term over here. Notice that it's only the time that gets squared. It's not AT multiplied together squared, it's just the time that's squared. Okay? All right, so now in reducing this a little bit further, I've taken my 10 multiplied by 4 to get my 40. 1/2 of 5 is 2.5, and 4 squared is 16. Go a little bit further here, and that's going to give me the answer, and that's 80 meters. Okay, let's see. Hopefully that worked out well for you. Yes, 2.5 multiplied by 16 is also 40. And that line was missing, but we jumped down to 80 meters, and that's the answer. Let's try another example to make it as clear as possible for you. Okay, so here's another one. We're looking for the acceleration. First of all, we identify the information, so there it is, and then we're going to plug it in for our solution. This time we're solving for the acceleration. So in plugging those numbers into our new equation, we'll end up with this. Nice here that the initial velocity is 0. That means this will cancel out to 0. Notice also again that it is only the time that's getting squared. All right, let's reduce it a little bit further. And let's see, 5 squared, 0 as I mentioned, multiplied by 5 is 0. 1/2 I'm still using, and then 5 squared is 25. And you can see again, it's only the time that gets squared. So reduce it a little bit further. Here I'm getting 12.5 by multiplying 1/2 multiplied by 25. And then my last step is the division. And that'll give me an acceleration of 200 meters per second squared. Hey, that means that every second it's going 200 meters per second faster than it was the second before. That's a lot of acceleration right there. That's a big pickup. Okay, so what kind of object could do that? What kind of object could have so much acceleration? How about a spaceship? That's a possibility. All right, well, oh, look at it go. There you go. All right, so let's see what else. Let's try one more here, and that'll end this short presentation and hopefully give you some success on the next assignment. Okay, so this time I'm looking for the initial speed. Really, in all of these problems, once we have an equation, I can ask you to solve for any of the missing pieces as long as I give you a way to find all of the other pieces of information. At any rate, here are the variables for this problem. So there's my first step, identifying. Then I am going to take my new equation and start plugging my numbers in. So there I go. All right, this time around, it's the initial velocity that I'll be solving for, but I will try to reduce everything as much as I can before I get there. And when I do that, this is my next step. I'm using 1/2 multiplied by 15. That's where the 7.5 comes from. And 4 squared is the 16. I'm going to reduce a little bit more to get my 120 over here. And here I'm back to an algebra problem again. This is tricky and gives people troubles, I know. It did for me when I was first learning also. I want to get two things away from the VI, the 4 and the 120. My strategy is to get rid of the thing farther away first, and I'll undo the addition with subtraction. So there's my subtraction, and that leaves me with 180 is equal to VI divided by 4. And now, to get rid of the 4, I'll undo that multiplication with division, which will look like this, and that gives me my initial velocity of 45 meters per second. Well, I hope this was helpful for you, this short presentation. If you have any questions, bring them to class, and why don't you give that next assignment a try. It should be possible now, a little bit more challenging because there are 3 equations to be dealing with. Okay, look forward to seeing you in class the next time. And remember, let me know, is it better without my face or with my face? No offense will be taken.